are moving on to CO14, and we're going to talk about a whole bunch of different postulates. Unfortunately, these ones don't have fancy names like the segment addition postulate or the angle addition postulate or the vertical angles congruence theorem. These are just postulates. And so remember, a postulate is something that is known to be true in geometry, and you can use it in proofs. We are not going to be using them in proofs too often just because they don't have catchy names. We'll kind of stick to the main ones. However, they can help you interpret what's going on in a diagram such as the one that we have here. Okay? So, not even I have these things memorized. If you were to ask me what is postulate 8, I'd look at page 96 in my book and read it to you. But I don't expect you to know these by name either. I expect you to know the relationship. So, number 5 actually, postulate 5. Through any 2 points, there exists exactly one line. Through any 2 points, there exists exactly one line. Through any 2 points, I didn't stretch enough. There exists exactly one line. Yes?
Why? What is postulate for?
So like the segment addition postulate, that is postulate 2, right? So it has a fancy name. Who named them? Someone way more important than us.
Why
What
name
could
it?
have been his name of
I
like
You're
that.
saying
You know,
that?
so
We all have human
dignity.
dignity! You're saying some stupid mathematicians were. We all have it.
addition, far
We
from
all have inherent dignity.
Wow.
Oh.
Okay. Woo. So there are some that are used very, very often. The segment addition postulate is a kind of like how some NBA players just have one name. Kobe. We all know who Kobe is, right? Magic, right?
What's that guy?
Ant.
Oh,
Okay?
Ant.
So, you know, some postulates are just so important, so frequent that they've got special names for them. The other ones aren't as important. I didn't say that. They aren't as used that frequently. Who named them, Hugo? I don't know.
You can't really say Brian. I think that's
I don't know that either.
What about cat?
Cat. Sure. Big cat, exactly.
I think of
Postulate 6.
I think of Emmett.
Oh, it's got it right here. Hugo, let me answer your question totally from my brain. Postulate 1 is the ruler postulate, which says you can measure stuff with a ruler. That's why we didn't talk about it, because you learned that in kindergarten. Postulate 2 is the segment addition postulate. Mentioned that one. Postulate 3 is the protractor postulate, which we skipped because I don't have enough protractors for you all. And postulate 4 is the angle addition postulate. I just didn't understand your question earlier. That's why I didn't have all that right there. Mario.
Some guy just made some fancy name saying that you can measure things with a ruler.
Yeah, exactly.
I named it postulate 1.
Anyone.
I know.
See, that's the disadvantage of being alive in 2024 is that all this stuff that you could have named if you were born in like 24, you know, now it's already been done.
Yeah.
So, yeah, it's, you know. Anyway, postulate 6. A line contains at least 2 points. Groundbreaking information today. A line contains at least 2
Is
points.
the next one gonna be?
Isn't it endless though?
At least 2. Yes.
Isn't
Yes.
it endless?
But at least 2. Meaning that to make a line, you only need 2 defined points. Think of like slope intercept form. When we graph a line on the corner plane, right? How many points did we use? 2. There's an infinite number of points contained in the line, but we only needed 2 of them to make the line. Once we make the line, we can see all the other points that are on it. But to create the line and to graph the line, we only needed 2.
So could they just say a line contains infinite points?
What they're saying is that in order to make a line, you only need 2 of them. That's what they're saying. Okay? Postulate 7, this one's wordy, here we go. If 2 lines intersect, then, well, this is like a conditional statement, then their intersection is exactly 1 point.
Oh, no.
That wasn't
Not
that
like
long.
simplify this definition.
It's not that.
You can abbreviate however, you could write the number 2 instead of the word 2, that might save some space.
And instead of 1, you could write the number.
Maybe you don't put a comma after intersect, but you know, you
Oh,
do
that's
you,
like a
man.
lot of space. That's it.
You do you.
Barely.
Postulate number 8, another wordy one, here we go. Through any 3, I'll leave it up to you to write out the word 3 or put the number 3, whatever you want to do. Non-collinear points, what does the word non-collinear mean?
They're not on
Not
the line.
collinear.
Not on a line, okay? Collinear means they are on a line, non-collinear means they're not on a line. So through any 3 non-collinear points, there exists
Triangle.
exactly 1
Triangle.
plane. Which is kind of like what a triangle is for connecting 3 non-collinear points, yes. Through any 3 non-collinear points. And we actually defined this one back in CO1 when we talked about planes. We said to have a plane, you needed 3 points that are not on the same line, and around them is a plane, right? We call the plane ABC or plane R or whatever. So we've talked about a lot of these before, but now we are officially giving it a number. 8.
Yay.
Yeah.
Where's your buttons for that?
Oh, I haven't used those in a long time. I should bring those back.
Yeah,
They're
well,
fun.
where did they go?
They're just on my task bar, my toolbar. Yeah. I haven't found a McDonald's one.
Can we get it?
I gotta figure out which one to cut though. 'Cause I can only have 10 or 20.
Cut the one you literally
Don't
never
cut the
use.
ha-ha.
Yeah, cut the one you never use.
The MCU? Alright, gone.
Cut
Postulate
the-
I'm
9.
really smart.
A plane. You're gonna hate this one. A plane contains.
I spelled plane wrong.
What? I spelled plane wrong?
No, I spelled plane.
Oh.
At least
A plane contains at least 3
points.
non-collinear points, Hugo. I'm glad we're talking about this one now. I'd hate to have you leaving the room confused. A plane contains at least 3 non-collinear points. In case postulate 8 wasn't clear enough,
Why would we hate it?
because it basically says the same thing as postulate 8, it's kind of reversed.
I don't really get this guy.
I'll see it. I don't understand.
Yeah.
What if I just make all this stuff up as I go?
Honestly, that's fine.
You know?
What is-
Postulate 10, bring your teacher a gift every single day. That's what it is. That's what it is.
Never
Oh,
go.
what
Never
bomb.
go. Yeah, I think
Here's
that's-
another wordy one, postulate 10. If 2 points lie in a plane, lie in a plane,
Like lying, like there.
like are in the plane,
Oh. Like-
then the line containing them
Is on the plane.
lies in the plane.
Is that what I said?
Oh my god.
I don't like this
Then
one.
the line lies on the plane.
Very important information being transmitted today. Why am I not being observed today? Of all days, this would be the one. Got some high level stuff going on here. Okay?
I think they planned
what
to
is
leave
that, though?
before you did this lesson.
I definitely intended for that to happen, yes.
This must have taken a genius to come up with.
Postulate 11, this one might actually be new for you. Postulate 11 says, if 2 planes intersect,
It's actually like the first thing.
so we have one up above where postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. If 2 planes intersect,
It's more than one.
their intersection is a line. Okay, their intersection is a line. If you have 2 pieces of paper, 2 planes, that you kind of intersect, put together. They don't intersect just one point, right? It's that whole line that the planes would intersect through. So that's what this is talking about here.
What if I do this? What if I just do this?
Because planes are infinite and go on forever,
Oh, yeah.
it would still be the case. But good thinking, Hugo. You really want to challenge some of these. You want your
This
own
guy was
postulate
probably
Hugo.
like super smart.
Postulate Hugo. Someday I'll be teaching that. Can't wait for it.
Wait, did you make these lessons? Still alive. Like, did you make these lesson plans? Like all of this?
Yes.
So if all of this is just like a bunch of lies, you're basically saying.
Well, not lies. I didn't say they're lies.
Hey, that's a good
That's not what I'm
idea.
saying. I'm saying they're lies. I know they're not lies.
I could become a building.
Wait, so you want to?
I didn't make all these things up. If that's what you're suggesting.
So,
I can make
I
a
did.
business.
Yeah.
Yeah.
so you spend time to make this?
Yes. Well, no, that I got from the Google. Yeah.
I could have just looked it up.
Yes. You could have looked. Yeah.
Could have looked it up and had it printed out, like picture.
Correct.
So
Then why
you're
didn't
making
you
us
do
write
that?
all these times.
Why did I do that?
Why did you make us write it?
Because I didn't.
Yeah, why do you make us write this? Because he doesn't like us.
Because when you write something, your brain remembers it more.
I know.
Some people-
It's
some
science.
have different
I don't care.
It's science.
I have to write stuff
Well,
3
this is
times in a
math
row
class.
for it
It's
to
science.
get in my brain.
Do you really think?
That's why I have never failed a
Do you really honestly think that if I didn't have this stuff organized and written out the way that I presented to you, you would take these notes in your notebook? You take the time to write. You would write P5, and like it wouldn't make any sense. Like this is guided note taking what we have here.
I don't think.
I like no note taking.
Plus, it'd be so long to make these things. I'm gonna use them forever. I'm gonna get my money's worth out of them. So there came a time when I was first writing these. I was one day ahead of the kids. I was like, okay, tomorrow, 13 or 14 comes after 13. So CO14. What should that be? Okay, this. And then I'd write the sheet and then print it out in the morning before school and give it that day. Like there's a time when I was
That's
putting these
good
together,
teaching.
I was just one day ahead. That's all I had to be.
Now it's good.
Emily.
That's
You go.
We need to know all these for the test.
You need to know they exist, and you need to know kind of what relations, but I'm not going to ask you what is postulates at. Yeah. For the test, everyone got these now?
Yeah.
Okay. If you don't, they're on page 96, I think I said this above. What the test will be like is the diagram down below. Identify which statements can be concluded based on the diagram. So all points shown are coplanar. Can that be concluded based on the diagram?
What's complete?
Coplanar means they're part of the same plane. So collinear would mean same line. Coplanar means the same plane.
How do I know that one line isn't like going off, like going off the line?
Points are.
Well, it is going off the plane because both lines and planes
Yeah, but all
are
the
infinite.
points.
these
All the
Okay.
points.
But these ones could be going up instead of
People,
going back.
the points.
If that were the case, your line would be like going through the page, kind of like a pencil would be going through a piece of paper. You'd be able to see it coming down like that. Okay. So are all those points contained within the plane? Yes.
Check mark. Huh?
That's all we write is yes.
That's all you need to write is yes.
I like this.
The next one, G, F, and E are collinear. Can we conclude that based on the diagram? Look for point G, Emily, point F, point E. Are those three collinear?
No.
How can you conclude that based on the diagram?
Co-living.
Because she's just up there.
You did not teach me that. I don't
We don't know, okay? Because how many points do you need to make a line? Two, right? So if it only said G and F, yes, because that's just 2 points. If it only said F and E, yes, that's 2 points. But adding that third point in there, we don't know whether or not they are collinear points.
Wait, collinear means on the same line.
Correct. There's no line drawn through them. We cannot definitively conclude one way or the other. Aiden.
Can that plane be three-dimensional?
What's that?
Can that plane be three-dimensional?
No, a plane is a two-dimensional space.
What is a 3D?
What about the
Polyhedron is where you get into that. Polygons are two-dimensional, polyhedrons are three. Evan?
What if it's a G and E? Would that be?
Yes, if it only had 2 points, then yes, because between any 2 points there can be a line. That third one in there changes things. You know, if one of them is slightly above or below the rest of them, then it's not going to be linear. Yeah,
Wait, so the lines could be invisible?
it's just not marked.
So it's
They could be on the same line, it's not marked, we don't know. Okay? Stop. Okay. The next one, angle AHB and BHD are a linear pair. It's good to go back and review this because how you read these things is important. Remember, when it says angle AHB, okay, it means it's starting at point A, H is the vertex, it continues through point B. The order of those points matters as far as where your vertex is, right? So AHB starts at A, goes to vertex H, and goes out to B. There's angle AHB right there. BHD starts at point B, goes down to point H,
Yes.
and goes through point D. Are they a linear pair? How do you know that?
Because it's a line.
They are two angles that
Are on the same line?
make a line. Okay, so yes. All right, go ahead and work through the rest of them. We'll talk about answers shortly. I will pause the video if I remember how to do it. I think I go this way. And we are resuming. Raise your hand. BF and CE. Line BF and line CE do not intersect. Evan. Lines BF and CE do not intersect. You say that is true or false? True. Why can't we conclude whether or not they intersect?
Yes, no, yes, true.
Because they just got adjacent.
Well, we're talking about lines. Lines can't really be adjacent. The angles can be adjacent. What would determine whether or not BF and CE? Well, I should say actually. When I say true, what I mean to say is no, we cannot conclude that. Is what I said. Okay. Why can't we conclude? Why is it true that we can't conclude lines B, F, and CE do not intersect? James.
It's gonna be like one thing off, and it's not parallel.
Right. So what we need to look for, Evan, Christopher, what we have to look for is whether those lines are parallel. And there's not enough information for us to determine whether they are parallel or not. Therefore, we cannot conclude whether they intersect or don't intersect. Okay, stop. Angle BHA is congruent to angle CJA. So BHA goes from B to H to A, C to J to A there. These two angles, can we conclude whether or not they, I put the markers in this so we can see them. Can we conclude, Audrey, whether or not they are congruent? We cannot. There are no markers, there are no letters, there are no arcs drawn. We cannot conclude whether they are or not. AHF and BHD are vertical angles. AHF is right here. A to H to F. B to H to D is right here. Are they vertical angles?
Yes.
Yes, they are.
Well, but usually they have the little arc things.
Yep, but the fact that they are opposite each other at an intersection, the arcs are not necessary. You can add the arcs in, but based on what we see, they intersect at a point. They are opposite angles at a vertex. We can conclude they are vertical. A, H, J, and D are collinear. A, H, J, and D. Yay or nay? Emily. Yep.
Yay.
Oh, wait, that one?
A, H, J, and D are collinear.
Yep.
Yes, they are. They're all part of the same line. They're all on the same line. AD and BF intersect at H. Lines AD and BF intersect at point H.
Yes.
Yes, they do. And AHB, angle AHB is 90 degrees.
No.
No.
Oh, no.
Okay? Alright, no homework for tomorrow. That is how you manage.